equality here. If B is greater than A, then we use this one. If B is less than A, then we use this one. So the definitions can fit in any case. Then as you can see, in this case, if we interchange here for this case, these are negative. If we put the minus sign outside, then this becomes to the original definition. See? From B to A. Okay? So this is really good. Suppose F stands for a force. Force. Integrate from A to B f of x dx means positive, 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 positive. Positive, 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 positive. So the work done by this force will be positive because suppose we have a spring. From A to B. From A to B, oscillation from A to B, and or in this case the force should be anyway, not exact spring. I mean, there is a force, an object at x, he got a force, f of x. To the right is positive, no. To the ceiling means positive. Okay. So the work done by the force with this displacement is this area. If from A to B, then the work is positive. From B to A, now your displacement is opposite to the force. So the work is negative. The work is negative. Force is also positive, but now displacement is negative because the direction of force and the displacement are opposite. So we got yes, negative work. 所以这个定义呢还不错哈。From A to B, just like a particle from A to B, or from here to here. If you interchange the limits, then we obtain a minus sign in front of the definite integral. Okay? 所以这个定义是很合理而且很自然的。你可以把小 f 当成力，那么 x 当成位置，这个叫位力啊，这跟位置有关。于是这个位能多大呢？你看这个力对这个节点做功嘛。从 A 到 B，F 只要上代表正的，代表在实际的情形 F 是指右边是正的啊，所以说正功。一样的力，它只跟位置有关。如果你是从这个地方往回走，就会发现从 B 往回走，这个位移是负的，力是正的，这个位移方向相反，自然这个做负功。所以从 A 到 B 做的功是正功，从 B 到 A 做的功是负功，可以吗？在这个地方力呢指向右边，在这个地方力呢 还是指向右边，但是从这边走过来的时候做正弓，那倒走回来的时候呢，位移跟这个地方相反，自然就是变成负的。所以从 B 到 A 是做负弓，跟 A 到 B， 当你这边颠倒的时候 ，A 在下面跑到上面去了 ，B 在上面跑到下面去了，加个符号。第二个，如果 A 跟 A 一样，代表跑了半天，没有做弓哈。Okay, if from A to A, from A to B is positive, from B to A is negative, cancel, 0. This also shows an additive property of the integration. Okay, if f is integrable on some interval, and a, b, c are points, for example, a, b, c. A, B, C may be same, may be distinct. And the orders, there are 6 possible orders. Maybe ABC, ACB, BAC, BCA, CAB, CBA. But no matter what orders or what order it is, this is always true. For example, from A to B means uses force, positive work. Equals from A to C, plus from C to B, reverse. So plus, minus, cancel, finally, from A to B. Okay. 所以说，这个不管 A、B、C 的任何的顺序，3的阶乘6种可能的排列大小，永远可以用这种接的方式。从 A 到 B 可以看，从 A 接到 C 是正的，加上从 C 到 B， 这是负的，正的跟负的消掉，还是从 A 到 B， 可以吧？这个就是所谓的 additive property of integration. We call this property additive property. Additive property. And A and B are linear property. And C monotonicity. Just give them names. Well, so the next will be the very important, and very famous, and very important theorem called fundamental theorem of calculus. Yes, the last hour about the velocity and the area is in the section 4.1, and the properties of integration, definite integrals, is contained in section 4.2. So I already skipped some examples. fundamental theorem of calculus. The fundamental theorem of calculus. Fundamental means that it must be very important. Okay, so our textbook divide this theorem into two parts. Part one. Suppose f is continuous on this closed interval a b. Then we can define another function, g of x, which is trying to be from a to x, f of t, dt. Oh yes, something I should mention here about the differential. dt means if integrate this function with respect to t. This variable is called dummy variable. Dummy variable. This variable. For example, if we consider in xy plane, then the partition and the Riemann sum is of the form then that it goes to infinity, then we obtain this. Now, if this plane is UV plane, the same function, but this time we use V as dependent variable, U as its independent variable. Then this time this is U0, U1, U2, Un. And the Riemann sum will be I equals 1 to n f ui star delta u. So we express this limit of Riemann sum as, because use u from a to b, f of u du, exactly the same object. Finally, suppose this is t at s. S equals f of t, the same function. Again, the same partition. Because we are in a TS plane. So this is T0, T1, B is Tn. Now the Riemann sum becomes summation I equals 1 to n f Ti star delta t. So we express this limit of Riemann sum by integrating from A to B, f, the integrand with respect to t. So, as you can see, use this notation, or this notation. They are all stands for the same limit of finite sums. That's the reason why you can use any later replace t by any other later. If you write x here, will make some confused here. Okay. What is G? If any x between A and B, G of x is defined to be from A to x. Oh, from A to x, FTBT, delta t. So G of x is exactly this area. G of x is this area. If f is continuous and non-negative, then g of x is here. Okay. When x equals a, when x equals a, from a to a,